Welcome to VAK's lecture. In this video, we will discuss about different types of data structures. Here we have two types of data structure. One is linear data structure and other one is nonlinear data structure. Let us discuss this one by one. In linear data structure, all the elements are stored in sequential manner. For example, we have arrays, queue, linked list and stacks. These data structures are called linear data structures. There is one more way we can say that a particular data structure is a linear data structure. When each element of a data structure has only one predecessor and one successor, then we can say that data structure is linear data structure. In this example, each element is having only one predecessor and one successor, right? Although there is one exception also. The first element and the last elements you can see very clearly. The first element has no predecessor and the last element has no successor. So this is an exception. Now we will discuss about nonlinear data structure. In this, elements are not arranged in a sequential order. For example, we can take tree data structure. This data structure is nonlinear. Why this is nonlinear? In this, you can see that each node doesn't have exactly one predecessor and one successor. You can see that this node has one predecessor and doesn't have one successor. It has two successors, right? So clearly, this data structure is not a linear data structure. We have another example, that is graph. Graph is also a nonlinear data structure. After understanding the difference between a linear and nonlinear data structure, let us even go further. We can make even further distinction, static data structure and dynamic data structure. Now we will discuss about these two. In static data structure, the memory is allocated at compile time. Therefore, maximum size is fixed. The advantage of static data structure is that we can access the data very fast. But on the other hand, the disadvantage is slower insertion and deletion operations. For example, array data structure is static data structure. Here you can see that we have to fix the size beforehand. That's why we are fixing the size at compilation time. That when we are creating the code, maximum size is always fixed in the case of arrays. Later we will discuss this, why this disadvantage is there and why this advantage is there. Right now you just understand this point that we can access the data fast and insertions and deletions can be done in slower manner. Now let us see what are dynamic data structures. In this dynamic data structure, the memory is allocated at runtime. Therefore, the maximum size is flexible. If the memory is allocated at runtime, then user will decide the size. So, the size is flexible. The advantage is faster insertion and deletion. Again, the disadvantage is slower access. For example, linked list is the dynamic data structure. We will discuss this later, that how linked list can be created and what are the advantages and disadvantages. We will discuss all these in subsequent lectures. And we can clearly say that there is nothing like one data structure is better than the other. The advantage of one is the disadvantage of another. So, the choice of data structure is purely depends upon the user requirements. According to that, the data structure will get selected. If you got to learn anything from this video, please like the video, share it with your friends and subscribe my channel and also hit the bell icon for more interesting new updates. Thanks for watching.